Hi, I'm going to tell you a little bit about the calculations that you'll need to do for the solutions laboratory that's coming up this week. So first of all, I'd like to remind you about concentration. What is concentration? Because we've talked about solutes and solvents and solutions, but let me just remind you, concentration is the amount of solute that is dissolved per volume of solution. And of course, the way we're going to talk about concentration, the units we're going to use in this lab will be moles of solute dissolved per liter of solution. Now I think it's always best to write out moles of solute per liter of solution. But there is a name for this sort of concentration, and that is molarity. And molarity is abbreviated big M. So whenever you see big M, write in moles per liter. Because if you just think big M, you might forget that you actually have a numerator and denominator whenever you see big M. So that is the concentration. Okay, so what are different ways that you can make solutions? And in this laboratory, there are two ways to make a solution. And I'm abbreviating solution SOL''N. And here they are. Number one is you can make it from a solid solute. So you weigh out the solute and you use that to make the solution. The second way that you're going to be doing in this laboratory is that you can make it from a more concentrated solution. And when you have a more concentrated solution, what you're actually going to do is dilute it. That concentrated solution is called a stock. Okay? So those are the two ways. You're going to be doing both of those ways in the lab. And I thought I would just go through some sample calculations for you, because then in your pre-lab you'll have to actually do some calculations for the lab. So let's go through some samples, and I'll do that first one first. So let's say that you have to make a solution from a solid solute. So let me give you an example problem, and this is number one. Make a solution from a solid solute. So here's an example. Let's say you need to make 100 mils of a 0.400 big M, okay? Again, big M, you just saw what that means. It's moles per liter. So you're going to take a 0.400 big M, and let's make it sodium sulfate solution. Now the question is, if you want to make this much of that concentration solution, how much or how many grams of sodium sulfate should you weigh out? So let me just draw actually a little picture for you. You're going to weigh out a certain amount of the sodium solute, and these little dots I'm making right there, they're supposed to represent the amount of solute. And it could actually be moles, but in this case, the amount of solute is going to be in grams. So that's how much you're going to have to weigh out. And then how much you want to make, that'll be the volume of the solution. These are just little icons I'm writing to help you keep track of things. And I've drawn this little funny little symbol because you'll see that in the lab we're going to be using volumetric flasks, which have sort of a bulb on them, and they sit on the table, and then they'll have a little line up that will measure out exactly the volume in the solution. And then ultimately you're going to put this solute in the volume, you're going to bring it up with water, and you're going to make a solution. Like so. And I know these two look different, but you'll have to use your imagination and imagine they're exactly the same. So this is the solution, and it's of a certain concentration. And again, the concentration is in big M, which means moles per liter. Okay, so the first thing we have to do is actually do a calculation and figure out how many grams of this stuff should we weigh out. Then we'll talk about how to make it. So what we want is grams of sodium sulfate. And what we're going to start with, what we got, and what we're going to start with is the volume of the solution. 100 milliliters of solution is what we want. Now, the first thing we're going to have to do is to get that mils into liters, because moles per liter is going to require us having a solution volume of liters. So we'll just do a really simple conversion. There's 1,000 mils in 1 liter. And right away, we've taken care of that problem. And now we have the solution that we need in liters. Now what you do is you multiply it by the concentration. But notice that I'm actually writing down moles per liter, not big M. And you can see why. Because when I do that, then the liters cancel out, and now I have moles. And moles, 0.4 moles times 100 divided by 1,000 is the amount of solute I want. But it's not in grams, and we need it in grams. So what do you think? We're going to need some sort of conversion ratio with a mole on the bottom and grams on top. And yep, this is the molar mass of sodium sulfate. So let's quick calculate the molar mass of sodium sulfate. So sodiums, we're going to need sodiums, 2 of them, it's 22.99. We're going to need a sulfur, which is 32.0. Oh, I think it's 7. I hope it is. And oxygen, which is 16, but we have 4 of them here. And if you add up all those pieces, you'll get 142.05 grams in 1 mole of sodium sulfate. So that number goes on top here. And now you can see what's going to happen is the moles will cancel. And we'll end up this calculation of starting out with our solution volume. Then we had to do a little cancellation, but then basically times the concentration. That's what's ultimately going to get us to the amount of solute we need. These two fractions here are just converting it into what we need. So if you do that calculation, I think you come up with 5.68 grams. Sig figs, I'm limited to 3 sig figs, so that's why I had to stop here. So let's go back to what we were doing. We had to go ahead, we want to make 100 mils of 0.4 molar, or moles per liter, sodium sulfate. We've just figured out that the amount of solute that we're going to need is 5.68 grams of the stuff. So how are we